Okay, students. These notes are from my class, Miss Chambers, and Miss Campbell's class for the week 4 geometry. This week, students, you will analyze proportion changes or scale factor of surface area and volume of solids. For these notes, you will need a pencil, notebook, and calculator. The type of questions you will be asked is, how do you determine the change in surface area or volume if you change the dimensions? And how to determine the scale factor of solids. On this particular slide, I have all the answers here. So what I'm going to do is I'm going to present from this current slide step by step. So how is the surface area of a rectangular prism affected in all dimensions? First of all, you have to know the length, width, and height. And with that, you can determine the total surface area, which is PH plus 2B. P stands for the perimeter, and B stands for the area of the base. In this case, the base is a rectangle. When you use the formula, you're able to get that the total surface area of the prism is 328 square inches. Now, if we want to change the dimensions by multiplying it by 2, then the new length, width, and height will be 12, 8, and 28. So all we did was simply multiply 6 times 2, which is 12, 4 times 2 is 8, and 14 times 2 is 28. Then we recalculate the surface area. When you recalculate the surface area, you get that the surface area is 1,312 square inches. So you want to compare the new surface area to the original surface area by ratio proportion. And so 1312 to 328, you have those two dots that come out to be 4 to 1. So virtually what you're doing is you're taking 1312 and dividing it by 328. Now, how about if we multiply the dimensions by 3? When we do that, that changes our length, width, and height to the following numbers, 18, 12, and 42. Notice that 6 times 3 is 18, 4 times 3 is 12, and 14 times 3 is 42. So that's why we have the new dimensions. So the formula changes to this with the new dimensions in place, and the total surface area comes out to be 2,952 square inches. When we compare the new surface area with the original surface area, when we multiply by 3, the new surface area compared to that would be written like this, 2,952 to 328. That comes out to be 9 to 1. What does all of this mean? Well, when the dimensions are multiplied by 2, then the area is squared, which is 4. On the multiplied by 3, when the dimensions are multiplied by 3, then the area is squared is 9. What does this mean? Well, my dimensions are for area are going to be squared anyway. So 13 to 28 comes out to be 4 to 1. So my scale factor is 2 to 1. So when I say I multiply by 2, that's like a scale factor of 2. So that's what the author is meaning.